Okay, so this is just to help you see how you could lay out your write-up of your controlled assessment practice piece on the sleep times versus the drop test and memory test. So we're always going to start with a kind of a hypothesis, aren't we? So in the plan section we would have hypothesis, hypotheses really, because we're going to have 3 linked ones. So I believe that I will find that someone who has more sleep will on average produce quicker drop test times and will remember more objects. If this is true, then when I draw a scatter graph of our sleep versus drop time, then there will be a negative correlation. Again, it's always important with your hypotheses that you try and state what you're expected to see, because in your planning stage you're obviously going to be saying what kind of graphs you're going to draw, what kind of calculations you're going to do, and so forth. I believe that someone who has more sleep will on average produce quicker drop test times and will remember more objects. If this is true, when I draw a scatter graph of hours of sleep versus drop time, then there will be a negative correlation. I also mentioned memory in there, so remembering more objects. So again, we'd go on and we'd add in more there. Don't forget, this is just an example, so I'm just going to put ... You'd be adding in more. Calculation wise, well, a linked hypothesis to this would be something like I also believe that I will find on average that males have less sleep than females, and I will also find that the standard deviation of the drop test times will be lower for females than males. Now, it's sensible to suggest using the standard deviation because the drop times is a continuous variable, so therefore we would expect a normal distribution for something that we measure. If it was a large sample, for this particular work, our sample size is going to be about 180 altogether with females and females, so that should be enough to see a normal spread. But we'll find out when we do the calculations. So we've got 3 hypotheses there. We've got one about drop test times will be lower for females than males. We've got one about sleep, and we've got one about how we'll see how the sleep time will affect the drop test and the number of objects remembered. So lots of things going on there which allow us to do lots of calculations. So for this last one here, we could say if these hypotheses are true, then when I calculate the mean average drop time for males, it should be for males it should be higher, as should the So again, we're talking here about what we're going to do, what we're going to see if we have got the hypothesis to be found to be true. So we're calculating the mean average drop time, and we're calculating the standard deviation too. Obviously this could be worded much better. Again, it's just examples of layout. So part of our planning should also be about the sampling and everything else. So we've got our hypotheses, so we're now going to talk about the population and the data. So population and data collection. Just highlight this, they stand out a bit. Hypotheses, population and data. Right, so in this section then, everything should be my and I, remember, because it's about your work, it's not somebody else's work. So my population is the school student body. It is split into year groups, but as I am looking at gender comparisons, then stratified sampling is not appropriate, as I just need to make sure that I have a large sample of females who do my test and a large sample of males who do my test. So, you know, for this particular project, then convenience sampling is just as valid as anything else. So I've chosen to do convenience sampling, as this is the easiest method to gather the data in the classes I will have access to. Random selection is not appropriate, as all the classes may not be available to me. And again, ... should be you giving me more reasons why you won't be choosing different samples. Okay, so convenience sampling literally means that, so I've chosen to do convenience sampling as this is the easiest method. This will mean I just find the classes in the school where a teacher will let me take students out of the classroom to sample to ask my questions, etc. again. So again, it's just really you've got to be you've got to be talking about the population and the sampling technique you're doing and the data collection. Okay, to allow me to collect the data, I will carry out a pilot survey to check my questionnaire and timings for my experiment. The experiment will be again ... because you'll be carrying out the experiments, you'll be talking about what you're doing and what pitfalls, limitations. So again, within the plan there should be a discussion on limitations, So that's access to kids and everything else. There should be a discussion on outliers, what you're going to do about them, how you're going to calculate them, and there should be a discussion on sample size. So again, there should be a discussion on minimum sample size. Your project will then move on to look at the analysis side of things. So in this section, you should be making sure that you talk about the types of graphs you're going to draw and why, and the types of calculations you're going to do. So again, this is all part of the plan as such, because this is the thing you've got to do before you actually carry out your project, because your plan should say everything you're going to do before you actually do it. So the analysis section is quite important. So you talk about the graphs and justify their choices, their choice, and you talk about the calculations you are going to carry out, and again, justifications needed. What do you expect to see from the calculations? So the analysis section should be full justifications throughout, and within the population data collections you've talked about your limitations, outliers and everything else. The conclusion section, so the conclusion section should be a discussion on calculations and graphs and how they reflect on the hypotheses. If you're not relating back all your calculations and what your graphs tell you in relation to your hypotheses, then you don't score very highly for this particular section. Then there should be an evaluation section. Now the evaluation could actually happen earlier in the work. If you, once you started your work, you could be talking about the evaluation as a way of changing what you're doing, because sometimes you find that what you thought was going to work is not going to work, and then you kind of evaluate and change it and collect your data in a different way maybe, or carry out different calculations because your data, for example, might have had tons of outliers and you decide to take another sample, or you might find that when you plot your box plot your data is skewed heavily, so therefore you can't calculate the standard deviation, so you decide to calculate different measures of spread. You might draw histograms and see that it's a normal distribution, and your evaluation suggests that you should be looking at introducing the normal distribution into your work in whatever way you decide is appropriate. So the evaluation should talk through limitations, reliability. So how reliable is your data? Is your sample size big enough? What would be the effect if you took a different sample from a different school maybe? What if you decided to introduce the project to adults? How do you think that would reflect on your data? Can you collect some secondary data to compare? Because obviously what you've done is some primary data. So there should be a thorough evaluation of all the things you did. Did the graphs do what you wanted them to do? Did the calculations do what they wanted them to do? If not, did you do something about it, etc. So you talk through the limitations of reliability and things you would change to improve the work. Okay, so that's just a brief outline of the kind of things that you should be doing in writing up your practice piece, and I look forward to reading them when you hand them in.